Bugs crashing your pack's party? Whether they've got paws or sneakers, your pack deserves a home that's protected from pests. That's where Wondercide comes in. Plant-powered protection made with steam-distilled natural essential oils that actually work. It kills and repels fleas, ticks, mosquitoes, and ants without questionable ingredients or overpowering smells. Safe to use around kids and pets when used as directed, lab-proven to work fast, and proudly made in the USA. We offer sprays for pets, people, homes, and yards. Plus, spot-on treatments, collars, and even shampoos. Whatever your pack needs, we've got it covered. Founded by a pet parent looking for a better way to protect her dog Luna, Wondercide's now protected over 21 million lives and counting. You might have even seen us on Shark Tank. Go to Wondercide.com and use code WONDER20 for 20% off your first order. That's WONDER20 at Wondercide.com. Wondercide. Protect your pack with plant-powered Wondercide today.
This is SpaceTime, Series 28, Episode 116, for broadcast on the 26th of September 2025. Coming up on SpaceTime, mysterious red dots in the early universe. Could there be black hole atmospheres? The discovery of multiple episodes of habitability on the red planet Mars, and the European Space Agency's newest Australian deep space dish about to begin operations. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers believe that a population of mysterious red dots spotted in the very early universe could be exotic stellar atmospheres around ancient black holes. The findings, reported in the journal Astronomy and Astrophysics, might represent a missing link in the rapid growth of supermassive black holes. Stellar mass black holes are created through the supernova deaths of massive stars. And those stellar mass holes can get bigger and bigger through mergers. But the discovery of supermassive black holes in the early universe has remained a problem. See, there's no way enough stellar mass black holes could have merged back then in the amount of time available since the universe began. And that's where these tiny red objects come in. They were spotted by NASA's Webb Space Telescope, and they're offering scientists new insights into the origins of galaxies in the universe. And they may represent an entirely new class of celestial object, a black hole swallowing massive amounts of matter and spitting out light. Using the first data set released by Webb back in 2022, astronomers who first discovered those mysterious little red dots suggested the objects might be galaxies that were as mature as our current Milky Way is, but at a time when the universe itself was only 500 to 700 million years old. That suggests that these so-called universe breakers are far older than anyone expected in the infant universe. And that calls into question what scientists had previously understood about galaxy formation. This new hypothesis suggested the dots may not be galaxies, but an entirely new class of object known as a black hole star. The authors say their analysis indicates these tiny pinpoints of light may be giant spheres of hot gas that are so dense they look like the atmospheres of a typical nuclear fusion-powered star. However, instead of fusion, they're being powered by supermassive black holes at their centres, which are rapidly pulling in matter and converting it into energy, in the process giving off light. One of the study's authors, Joel Leger from Penn State University, says as his team studied the red dots, they eventually found one that had so much atmosphere around it, it couldn't simply be explained as a typical star. They originally thought it could be a tiny galaxy full of many spectrotype M red dwarf stars, but instead it's actually effectively just one giant, very cold star. Most stars are low-mass spectrotype M red dwarf stars. In fact, that population makes up about 3/4 of all stars in our galaxy. They're typically hard to see because they're washed out by rarer, more luminous massive stars. Still, astronomers can identify these stars by their glow, which is primarily in the red optical or near-infrared end of the electromagnetic spectrum. While the gas around supermassive black holes is typically very hot, millions of degrees Celsius, the light from these red dot black holes was instead dominated by very cold gas. And that's similar to the atmospheres of low-mass red dwarf stars, based on the wavelengths of the light they're giving off. The most powerful telescope in space, Webb, was designed to see the genesis of the cosmos using infrared sensing instruments, which are capable of detecting light that was emitted by the most ancient stars and galaxies. Essentially, Webb's allowing scientists to see back in time roughly 13.5 billion years, pretty well near the beginning of the universe as we know it. And from the moment the telescope turned on, astronomers around the world began seeing these little red dots, objects that appeared to be far more massive than what galaxy models predicted. At first, they thought these objects must have been mature galaxies, which tend to get redder as the stars inside them age. But the objects were too bright to be explained. Those stars would need to be packed inside galaxies at impossible densities. If this interpretation holds, it implies that stars form through extraordinary processes that have never been observed before. To better understand the mystery, the authors needed spectra, a type of data that could provide information about how much light the objects emitted at different wavelengths. So between January and December 2024, astronomers used nearly 60 hours of Webb observation time to obtain spectra from a total of 4,500 distant galaxies. And that makes this one of the largest spectroscopic databases yet obtained from Webb. In July 2024, the authors spotted an object with a spectra that indicated a huge amount of mass, making it the most extreme case of such an early, large object. Astronomers nicknamed the object the Cliff, flagging it as the most promising test case yet to investigate exactly what these little red dots were. The extreme properties of the Cliff forced astronomers to go back to the drawing boards and come up with entirely new models. This object was so distant that it took light almost 11.9 billion years to reach the Earth. The spectral analysis of that light indicates it was actually a supermassive black hole, pulling in surrounding material at such a rate that it cocooned itself in a fiery ball of hydrogen gas. So the light wasn't coming from a thick cluster of stars, but from just one single giant object. Supermassive black holes are found at the centres of most, if not all, galaxies. In some cases, those black holes are millions to billions of times more massive than our Sun, pulling in nearby matter with such strength that it converts to energy and shines. No one's ever really known why or where these gigantic black holes at the centres of galaxies come from. And these black hole stars may well be the first phase of formation for these supermassive black holes. Webb's already found evidence of high-mass black holes in the early universe, and these new black hole star objects, which are essentially turbocharged mass builders, could help explain the early evolution of the universe, and may therefore be a welcome addition to current models. This is SpaceTime. Still to come, discovery of multiple episodes of habitability on the red planet Mars, and the European Space Agency's newest Australian deep space antenna about to begin operations. All that and more still to come on SpaceTime. NASA's Mars Perseverance rovers discovered strong evidence the red planet's Jezero crater experienced multiple episodes of liquid water flooding, each with conditions that could have supported life as we know it. By analysing high-resolution geochemical data from the six-wheel car-sized mobile laboratory, scientists have identified 24 types of minerals that help reveal a dynamic history of volcanic rocks which were altered during interactions with liquid water on the red planet. The new findings, reported in the Journal of Geophysical Research Planets, provides important clues about the ongoing search for ancient life on Mars. The study's lead author, Eleanor Moreland from Rice University, says the minerals in Jezero support multiple temporarily distinct episodes of fluid alteration. She says it indicates there were several times in Martian history when these volcanic rocks interacted with liquid water, and therefore more than one time when this location hosted environments which would have potentially been suitable for life. Minerals form under very specific environmental conditions of temperature, pH, and chemical makeup of fluids, and that makes them reliable storytellers of a planet's geologic history. In Jezero, the 24 mineral species they've found reveal the volcanic nature of the Martian surface and its interactions with water over time. The water chemically weathers the rocks and creates salts or clay minerals, and the specific minerals that form depend on the environmental conditions. The identified minerals in Jezero reveal 3 types of fluid interactions, each with different implications for habitability. The first suite of minerals, including greenolite, isingolite and ferroaluminoselenite, indicate localized high-temperature acidic fluids that were only found on rocks on the crater floor. And these are interpreted as being some of the oldest rocks included in the study. The water involved in these episodes is considered the least habitable for life, since research on Earth has shown that high temperatures and low pH can damage biological structures. Now, while these would be most challenging for life, on Earth, life can still persist even under these hot, acidic conditions. We're talking about the geothermal geyser pools of water at Yellowstone, so it doesn't rule out habitability. The second suite of minerals reflects moderate, neutral fluids that support more favourable conditions for life and which were present over a larger area. Minerals like minnesotite and clinoptilolite formed at lower temperatures and neutral pH, with minnesotite detected on both the crater floor and in the upper fan region of Jezero, while clinoptilolite was also detected on the crater floor. Finally, the third category represents low-temperature alkaline fluids and is considered quite habitable from an Earth-type perspective. Sepiolite, a common alteration mineral on Earth, formed under moderate temperatures and alkaline conditions and was widely found distributed right across Jezero. The presence of sepiolite in all these areas reveals a widespread episode of liquid water, creating habitable conditions in Jezero crater and in filling sediments. Moreland says these minerals are telling scientists that Jezero experienced a shift from harsher hot acidic fluids to more neutral and alkaline ones over time, conditions increasingly supportive of life. Because Mars samples can't be prepared or scanned as precisely as Earth samples, the authors developed an uncertainty propagation model to strengthen their results. Using a statistical approach, Moreland and colleagues repeatedly tested mineral identifications, considering the potential errors, similar to how meteorologists forecast hurricane tracks by running many models. And the results confirm that Jezero, once home of an ancient lake, experienced a complex and dynamic aqueous history. The new mineral discoveries not only bring scientists closer to answering whether Mars ever could have supported life, but it also sharpens Perseverance's strategy for which samples to collect for a possible future return-to-Earth mission. This is SpaceTime. Still to come, the European Space Agency about to commission its newest Australian deep space dish, and later in the science report, researchers finally confirm that people really do see colours the same way. All that and more still to come on SpaceTime. The European Space Agency is about to inaugurate its 4th Australian deep space antenna at its new Nausea tracking station in Western Australia. The new 35-metre parabolic dish will reinforce ESA's deep space communications capabilities, supporting upcoming deep space missions and meeting a growing demand for the deep space network. The new Nausea complex offers a strategic geographical position, complementing ESA's deep space antennas in Sweden, Belgium, Spain, Portugal, French Guiana and Argentina. They're all linked to ESA's European Space Operations Centre in Darmstadt, Germany. This report from ESA TV.
ESA, the European Space Agency, operates several missions in deep space and ensures that they meet their science objectives. Teams of specialized engineers design and deploy the technology needed to communicate with spacecraft that are exploring our solar system.
When designing space communication systems, we are confronted with strong constraints on board in terms of mass and power. Therefore, we try to move the complexity into the ground station, where we can build much larger ground stations with much more performance.
ESA has deep space stations around the world, organized in a network called S-Track.
We obviously need to receive data from the spacecraft. This is in particular scientific data coming from the instruments. It is navigation measurements, and it is status information from the spacecraft. On top of this, we need to command the spacecraft in order to navigate it and to operate it.
When receiving data from deep space, we want to collect as much signal energy as possible. ESA's antennas are 35 meters wide with the same surface as an Olympic swimming pool. The dish alone weighs 130 tons, and we can point it with the accuracy of 6 millidegrees to any position in the sky. The mechanical design makes it possible to compensate for the rotation motion of the Earth. All the received energy is captured by the large dish. It's focused on the so-called subreflector, and the signal is then guided to the base of the antenna, where special dichroic mirrors separate the incoming frequency bands.
Cryogenic amplifiers undertake the critical task of amplifying this weak signal coming from the space using high-tech semiconductor technology developed by European industry to boost this signal around 1 million times or 60 dB. The use of indium phosphide technology and cooling down to minus 260 degrees Celsius allows to generate only 5 degrees Kelvin of thermal noise, that is only twice the cosmic background noise, the lowest noise you can find in the universe.
The demodulated and decoded signal eventually goes through the SpaceLink protocol processing, which outputs the data in a format we can easily handle. This is the telemetry data that includes the low-rate data from the spacecraft platform and the high-rate data from the scientific instruments. Communication also needs to be in the opposite direction. We need to transmit the so-called telecommands to the spacecraft in order to activate thrusters or control our scientific payloads.
Typically, we need to transmit around 20 kilowatts of radio frequency power. This is done using klystrons. Klystron is a high-density energy device that transforms around 100 kilowatts of electrical power into 20 kilowatts of radio frequency power, amplifying the signal some 100,000 times, or what it is, 50 dBs.
The klystron amplifies signals by converting the kinetic energy in a DC electron beam into radio frequency power. The beam is passed through an input cavity resonator, and thanks to a phenomenon called bunching of electrons, in turn produces a high-power radio frequency field in the output cavity. Then, the signal following the same path as the download signals, but in the opposite direction, goes through the beam waveguide, made of solid and dichroic mirrors. It is then reflected by the subreflector onto the main dish and radiated into space. In order to navigate our spacecraft through the solar system, we need to know their position. This is no easy task at planetary distances. Therefore, ESA's deep space antennas perform radiometric measurements that allow us to derive spacecraft position and velocity.
Basically, what we conduct is three types of measurement. We range to the satellite. Today, we are able to resolve the distance of the satellite within 1 meter. We measure the radial velocity of the satellite with respect to our antenna to an accuracy which is below 0.1 millimeter per second. We can also measure very precisely the angle under which the satellite is seen. By combination of the three techniques, we are able to localize the satellite in a box of hundreds of meters to a distance between the Earth and Mars. This is especially important during certain critical phases, where you want to inject a spacecraft into a planetary orbit.
To achieve this level of precision, special range, Doppler and interferometric techniques are used, which rely on the stability of our ground clocks, typically 1 second deviation in 100 years.
We equip the antennas with very stable clocks, which are based on atomic transition, like hydrogen-based masers, which are able to behave in an extremely stable manner along the propagation time of the light across the measurements. These are times which range above or in the order of the hour. And during this time, the antennas must behave in a very stable manner.
Another important aspect is time synchronization. We constantly need to synchronize the clocks on board our spacecraft with the universal time coordinated we have on Earth.
The data received from the satellites must be assigned at the ground station, at the antennas, with a precise time tag. This time tag is required by the scientist to put in relation the data which is received by the satellite with their scientific models.
So our deep space network is built according to internationally agreed standards for covering radio frequency modulation, telemetry coding. This enables us to give cross support to external agencies such as JPL, the Chinese, Russians and Japanese. We have a ground segment reference facility which we use to replicate the same configuration that we have in our deep space network. In addition, we have a Faraday cage which we use to mount the flying transponder and onboard data handling system which we used to make representative compatibility testing for the flying missions.
ESA's deep space stations work at different frequencies, up to 34 gigahertz. The new challenge in space communication is optical communication, in particular in the infrared domain at 1 to 1.5 micrometers, corresponding to 200 terahertz.
Optical space communication direct to ground through the Earth's atmosphere is much more challenging because A, the beam is much narrower, and B, the atmospheric effects are much more prevalent. By the way, the narrow beam and the higher frequency is what gives us the high data rates. Based on ESA's heritage from the early days with Artemis and Spot 4 and the current generation of space terminals being deployed on EDRS and Sentinels, we will be able to build deep space optical communication systems.
ESA already operates an optical ground station laboratory at Tenerife, which will be used for the first time to demonstrate optical deep space communication from a spacecraft orbiting the Moon. Optical technology will allow unprecedented data rates from deep space, thereby maximizing the scientific return and enabling new types of missions, like planetary remote sensing as we are used today from Earth.
And in that report from ESA TV, we heard from ESA's head of Ground Station Systems Division, Klaus-Jürgen Schulz, ESA's Ground Station Subsystems Engineer, Salvador Martini, ESA's Head of Systems and Project Support Manager, Marco Lanucara, ESA Systems Project Support Manager, Kevin Kewen, and ESA's Head of Ground Station Subsystems, Igor Zaya. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims specific types of intestinal bacteria could be linked to insomnia. The findings, reported in the Journal of General Psychiatry, suggest the microbiome could even play a role in causing the condition. Using a technique called Mendelian randomization, which uses genetics to allow scientists to determine whether one thing causes another, rather than them just being linked, the authors found 14 types of intestinal bacteria that may contribute to the risks of insomnia. They also found 8 groups of bacteria that could help protect against insomnia, and that this link also works in reverse, and that insomnia could also cause the microbes to be altered. Scientists have finally confirmed that people really do see colours all the same way. The findings, reported in the Journal of Neuroscience, show that colours are represented and processed in the same way in the same parts of the human brain in different people. The authors were able to predict which colours a group of people were looking at by using a machine learning tool that was trained on the brain scans of a separate group who had been shown various colours. They found that different colours are processed by subtly different areas within the same brain region, and that different cells respond more strongly to specific colours than others. Scientists have identified a new species of stingray at a local Fijian fish market. A report of the Journal of Fish Biology claims researchers from the University of the South Pacific identified the new species, which they've named Fiji mascray. The fish is only found in local Fijian waters. Although the ray is common around the island nation and most widely traded in local markets, it's never actually undergone a detailed taxonomic description until now. And time once again for our silliest story of the week. An infamous, allegedly haunted Raggedy Ann doll, popularised in the Conjuring movies, apparently went missing after it was claimed to have started a fire during a psychic and spirit festival in New Orleans. Tim Mendham from Australian Skeptics says the story got almost hysterical coverage around the world, despite the fact that it didn't have an ounce of truth about it.
This is a story about a doll named Annabelle, which was supposedly a doll that was sort of infamous because it was possessed, haunted. It had paranormal powers. It could attack people. It could move. It could send messages. It attack people, doing all sorts of nasty things because it was possessed. It was in the collection of a couple of ghost hunters, Ed and Lorraine Warren, who are quite famous.
We've mentioned them before.
We have mentioned them before. They were quite famous. They're both passed away now. Ed Warren was a man who there was no haunting he ever saw that didn't exist. I don't think he was ever a debunker.
He loved
Every place was
Amityville, didn't he?
Amityville, a whole range of different things. Enfield in the UK. He was a big conspiracy theorist and everything. His wife was like a nicer lady, but she went along with it. How sincere they were, I don't know. I think definitely Lorraine. I think the wife was very sincere. I don't know about Ed. So anyway, this doll was in their possession, but it's been moved around a bit on display. People go and see it. It's a bit of a travelling circus. So it was down in Louisiana for an exhibition, and lo and behold, the fire broke out. So naturally, sorry?
Did the doll start the fire? Do we know?
That's the theory, of course. People instantly said this Annabelle doll started the fire. No reason to suggest that, just that the Annabelle doll was in Louisiana and the fire was in Louisiana. Now, the question was the Annabelle doll in Louisiana? Because then the rumours started that it had disappeared. So Annabelle doll, haunted, possessed being that it is, was running loose around the countryside because it had disappeared. Trouble was, fire, not associated with anything else, obviously. It was just a normal fire. And the Annabelle doll did not disappear. Even though this had headlines around the world, believe it or not, I've seen them from Indian newspapers and all sorts of places, that the Annabelle doll had disappeared and it was causing all this chaos. And I had to quickly point out Annabelle doll's not disappeared. We have it in our possession and it's going on to the next city on the tour. This fire is not associated with it. It is an absolute, apart from the fact that the doll is not haunted, probably, I think it's unlikely.
Oh, I see. You're going back to first principles, are you?
Yeah, I know. Yeah. Prove that this thing is haunted. Forget association with a fire or anything like that. Just prove that the doll is haunted, possessed. And I don't think it's a Raggedy Ann doll, with the big eyes and red hair and things, and someone's painted on some tears and it makes it look a bit more evil.
Doesn't the tear mean you've killed someone in prison or something?
Well, obviously this doll has attacked people. I don't know if it's ever actually killed anyone, but it probably has. I don't see why not. So there we have it. It's a strange thing. This disappearance didn't happen, the fire didn't happen, the doll's not haunted, but it makes a good story anyway. And it just got coverage around the world, which is the amazing thing. It's a pretty unimpressive doll. I've seen nastier-looking haunted dolls, mainly because people are painted on nastier-looking faces. It'll go on. It'll continue.
That's the way it gets. It's the same thing. I was just noting today that killer bees are back in the news in the United States. And it turns out that every year at this time, you'll find a killer bee story. They come out at this time of the year every year. You can go back 10 years, 20 years, you'll see them in the news that there have been killer bees seen. It's always at this time of the year. So there are these things which are constantly recycled. And Chucky dolls are one of them, yeah.
Yeah, there are certain sort of paranormalities that keep appearing. The UFOs are pretty persistent. Psychic powers are persistent. Other things come up and they go and they disappear, thank heaven. But there'll always be something to replace them.
Like 70s fashions.
That was pretty paranormal. If the Raggedy Ann doll is haunted, why aren't a lot more dolls haunted? Perhaps they are. Possessed dolls, that sort of thing. But I don't know. It's one of those things you just sort of put your head in your hands and you think, really?
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.